Hi, it's Carly McAvoy. I'm looking at a typical work problem. In this case, two things are working against each other. So we have a rectangular swimming pool that's being filled, water flowing into the pool through an inlet pipe, and the rate of the inlet pipe is such that it would take T hours to fill the pool. We don't know how much it would. That would be T hours if the outlet pipe were closed. However, there's also an outlet pipe that drains water from the pool. So it's working against that filling. When both pipes are open, it takes 4 hours longer to fill the pool than it would with only the inlet pipe. So if the outlet pipe alone could empty the pool in T plus 7 hours, find the time it takes for the inlet pipe alone to fill the pool. We're just trying to find that T. What time would it take for that to find that? And then it says round your answer to the nearest 2 decimal places. Well, what I want to say is that I know that T is the time to fill with the inlet pipe, and T plus 7, which is given, is the time to empty with the outlet pipe. And then because it says that it takes 4 hours longer to fill it if the pipe is open, that I know if the 2 pipes were open, one was filling, one was draining, it would take T plus 4 hours. So everything's based on T, the time it takes that inlet pipe to do that job on its own. So what we're interested in is what would happen in 1 hour. In 1 hour, we'd have 1 over T for what the inlet pipe was doing. We have 1 over T plus 7 for what the outlet pipe is doing. And we're subtracting these because water's coming in and it's taking away from that job. So we're subtracting the water that's going out. And then we know that in 1 hour, we have T plus 4 of the job done because that's how long it takes if both pipes are open. The next thing you have to do is find the LCD. We're just going to have to use all 3 of those denominators, T plus 7, and T plus 4, and then you multiply every term by the LCD. So we have 1 over T, we multiply that by the LCD. We have 1 over T plus 7, that gets multiplied by the LCD. And we have 1 over T plus 4, and that gets multiplied by the LCD. You don't have to write it 3 times, but I wanted to write it 3 times so you could see what's happening. And then how am I getting to this? Well, in that first term, this T cancels out this T over here. But what's left from here then is T plus 7, T plus 4. In the second term, the T plus 7 cancels the T plus 7, but what's left is the T and the T plus 4. We also have a minus sign there, so don't forget that. And over here, the T plus 4 cancels the T plus 4, and what's left is T and T plus 7. Next thing you're going to do is FOIL that. That's going to be T squared plus 11T plus 28. You're going to distribute this minus T squared minus 4 and distribute this to get T squared plus 7T. We're going to start cleaning this up, adding together what we can over here, combining things. You can see that T squared minus T squared is going to cancel. 11T minus 4T is going to be 7T, leaving us with 7T plus 28 and T squared plus 7T. I'll move that up for you. And so if you subtract 7T from both sides, those just go away, and we get T squared equals 28. And if we have T squared equals 28, we can find out what T is by taking the square root of both sides. Remember, when you take the square root of a perfect square like T squared, you get T, but there's really 2 possibilities. We have a positive and a negative possibility, so the square root of 28 is plus or minus 5.2915. But we're talking about time here, and we don't talk about the negative value as it relates to time, so we're just thinking of the positive one. Plus, remember, our directions up there said to round to the nearest 2 decimal places, so our answer is going to be 5.29 hours. Have a fantastic day. We'll see you next time.